My name is Kristen Partica. I'm the project manager of the Northern Grapes Project. Today's webinar is Stuck on You, Sulfur Spray Residues in the Vineyard and Winery with Gavin Sachs. His graduate student Jill did the session at noon today. Chris Gerling, who is part of the Extension Enology program at Cornell, is also online to help answer questions during the course of the webinar, so thanks, Chris. Gavin is an associate professor in the Department of Food Science at Cornell University. His research and teaching interests are in understanding the enological and viticultural parameters that shape wine flavor from vine to bottle. In addition to his research program, Gavin teaches courses in the viticulture and enology program. As I said earlier, remember that as a participant in tonight's webinar, we ask that you please keep your microphones muted if you have them. If you have any technical difficulties or have questions, please type a note in the chat pod over on the bottom right side of the screen. We're going to take a break during the course of the webinar to address some questions, and then we'll have time at the end as well. So Gavin, with that, I'll turn it over to you.
Thanks, Kristen. And even I think you said it was 7 p.m., and I just remember that's Eastern time. Looking at the list of names, there's a few people who identified where they are from, and
yes.
It looks like we've got several times represented right now. So as Kristen mentioned, my background is wine chemistry, and I work generally on analytical flavor chemistry. I do know something about viticulture and grape growing, but not a lot. If you ask me specific questions about the viticultural side, I'll do the best I can. If you keep pushing me, I will start lying. And if you keep going, I will start getting angry and ask you a hard chemistry. So, or just refer you over to Wayne Wilcox, my collaborator here at Cornell. Chris Gerling, who is also here, may have some ideas as well. And then Misha Kwasniewski is now at University of Missouri as a professor, and has a good grasp of some of the viticulture aspects too. So like I said, I'll do the best I can on the vineyard side, but if it gets too technical, I may have to cross-reference you to some of my collaborators. And then also before I get started, I wanted to mention our funding course. USDA has provided some support for funds, and Northeast Share, and also New York State through New York Farm Bureau Initiative has provided some support too. Okay, let's get started. So this picture here is a good example of why we spray sulfur in vineyards, especially if you are trying to grow vinifera, but also if you're trying to grow innovative hybrids in a disease-prone area with a high risk of a powdery mildew. So for today, what we're going to start with is what is elemental sulfur? Why do we use it, and what's the issues? Why can't we use it why shouldn't vineyard managers use it whenever they want to? From there, we're going to go to what are appropriate limits for sulfur, and how do we actually do that measurement if we want to know if we have on our grapes at harvest. And then next we're going to talk about some results from field studies looking at the persistence of elemental sulfur in the vineyard and where sulfur goes after you harvest the grapes. How much of it ends up in the must, how much in the juice, how much of it can then be converted into other things during fermentation. And then finally, we're going to show some yet unpublished work on whether or not sulfur residues might be one of several precursors responsible for the reformation of hydrogen sulfide and other nasty off-arms in bottle. That is, wines that go into bottle smelling just fine, and then they come out later reeking of something that is decidedly non-wine-like. So we'll come to that at the very end, but as a starting point, there's not going to be a whole lot of chemistry and chemical structures today. We're going to focus more on the phenomena and the empirical side. But it's one compound that's going to come up over and over, hydrogen sulfide. And when I say hydrogen sulfide, I am not talking about sulfites. That is, I'm not talking about the compounds that you would add to wine as a preservative. I'm not talking about sulfur, as you would spray in the vineyard. I'm talking about H2S, hydrogen sulfide, a rather noxious, rotten egg, flatulence-smelling compound. Indeed, there's actually a peer-reviewed research paper showing that one of two critical aroma compounds for the smell of flatulence is hydrogen sulfide. Probably the worst PhD project ever in terms of feeling bad for the unfortunate student who had to do it. And so when you ever describe a wine as having this smell, it's not that far from the truth. This compound has a rather low threshold. You need only a part per billion, an anagram per milliliter, to exceed sensory threshold. Rejection threshold, that is the point where someone would discard the wine or rate it as lower than the wine didn't have it, probably closer to 10 nanograms per milliliter. But it doesn't take too much of this compound to render it less desirable. And it's one of the primary contributors to what's called as a blanket term, reduced aromas or reductive or sulfur-like off aromas or SLOs. This can refer to a suite of sulfur-containing compounds that are responsible for this phenomena, but it's usually described as something that smells either burnt or skunk-like or rotten egg-like or rotten cabbage-like. Hydrogen sulfide is found in a very high percentage of wines, in excess of its threshold in wines that have this character. And one of the problems of H2S is its aroma, but one of the other problems is that it's reactive. And it can react with other compounds in wine to make even more potent, even more stinky off-aroma compounds. And in my opinion, the real danger of H2S isn't the H2S, it's what it can react with to make even unacceptable compounds once it's in the wine. Okay, so how the problem is H2S and other compounds associated with sulfur-like off-aromas. The data that you see up here is data from the National Wine Challenge, so it's several thousand wines. I want to say it's close to 10,000 some wines that are evaluated as part of a wine competition, and the judges, as part of their scoring, will mark whether or not wines are faulty. So these are not chemically validated evaluations, but evaluations by the judges as to what fault was present. And if you look through the numbers, the most common fault, almost neck and neck right now with cork taint, corked wines and musty off aroma, is these reduced aromas or sulfur-like off aromas. I was talking to someone who's participated in this before, and they said that 15 years ago, 20 years ago, all the problems were oxidation and cork taint. And no one knew what Brett was, so they didn't mark that, and reduction was almost unheard of. What's happened in the last 15 to 20 years is that the cork industry has gotten a hold of cork taint to some extent, and that's come down in frequency. Oxidation, people are much more, for the most part, much more judicious in their use of SO2, and they use better closers now. But as you use better closers, a better cork, or better aesthetic cork, or better screw cap, then what happens is that you've got a more anaerobic environment, a more reductive environment, which means you end up with more reduced aromas. So this is a consequence of some very good changes that have happened in the wine industry. We have less oxidation happening, but we've now swung perhaps more to the other extreme, which is more chance of reductive off aromas. Okay, so where's H2S coming from? Two pathways are very well established, and then there's some other pathways that probably contribute but aren't as easy to demonstrate consistently. The two that are best established are must nutritional deficiencies, which will lead to production of hydrogen sulfide by the yeast as they struggle to make sulfur-containing amino acids. All yeast, all fermentations will produce some amount of H2S, and you get more of it when there's some nutrient deficiency like nitrogen or some vitamins. The other pathway that's easy to demonstrate to lead to higher amounts of H2S is the presence of sulfur-containing pesticides, and particularly elemental sulfur. And so that leads us then to, why do we use elemental sulfur? Why is this pesticide by weight and by frequency application the most applied pesticide in the United States for grape growers, by far, by several factors. So the reasons are primarily to do with control of powdery mildew, which is a problem not just in our northern environments with cool, wet conditions, but pretty much anywhere where grapes are grown. They might not struggle from downy, they might not struggle from black rot, they will struggle with powdery. And one of the most effective ways of controlling powdery mildew is elemental sulfur. And this property has been known, well, at least for centuries and possibly for millennia. There's evidence that this was sprayed even back in Roman times. Over those millennia, we have not seen resistance develop by powdery. It's inexpensive. It's relatively non-toxic as compared to some other choices. And if you're going to do organic grape production, this is one of your only choices for powder control. But winemakers generally want to put restrictions on how late in the season elemental sulfur gets used. And the reason is that during fermentation, elemental sulfur gets converted into hydrogen sulfide. So there's H2S again, our stinky, noxious, volatile, malodorous form. And here's elemental sulfur. And during fermentation, the compounds produced by yeast in high quantities can react with elemental sulfur and convert elemental sulfur into H2S. And so the real problem with elemental sulfur and H2S formation, it's not just that it gets produced. You're going to make H2S even if you don't have elemental sulfur present in most fermentations, because the yeast will produce it as a byproduct of their metabolism. Here's the real problem. It's the timing. It's when it gets made. It's getting made late in the fermentation. So this is getting made after most of the CO2 is going to get formed. And so in a typical fermentation, you're making H2S early on. And and this is going to correspond to when CO2 gets made. A lot of it will get sparged out. That is, it'll get entrained in the CO2 gas that's being formed. And that's a real nuisance in the winery. But aside from being really stinky, it's not that. It's long term, it's not going to cause huge problems because it's no longer going to be in the wine. So elemental sulfur as a source of H2S, first of all, this has nothing to do with yeast nutrition. This has nothing, very little to do actually with yeast strain, a tiny bit of yeast strain. This will be produced by all yeast strains, regardless of your nutrient status and regardless of what type of yeast you're using and what type of temperature, because all yeast are going to make compounds that can react with elemental sulfur and convert it into H2S. Elemental sulfur is present. And it's dangerous because of when it gets made. It's late in fermentation and it doesn't get sparged out by CO2. So how much elemental sulfur is too much? This depends on reports, and the factor that varies amongst reports seems to be which yeast strain they used and how much background or native H2S production they were getting. Generally, people talk about somewhere between 1 and 10 milligrams per liter sulfur residue as being enough to create more H2S during fermentation. I tend to believe more the low end of this value, the 1 value. The 10 value seems to come from some yeast strains that happen to produce a lot of H2S naturally, and therefore would mask any production due to metabolism of elemental sulfur. How late you can spray to get to this 1 to 10 level, that also depends on who you believe. If you report from Germany and California, which says you can you can spray up to 8 weeks before, or do you believe this report from California that says that you can spray up to 2 weeks before having too much sulfur residue? And that's a pretty big range, 2 weeks versus 2 months. And so part of the problem with the reports we were looking at was you're relying on something which we expect to change depending on location, depending on how you're spraying, what formulation you're spraying. Ideally, this is something that you're measuring yourself. So what happens in the Finger Lakes with Riesling, with this particular spray that was being used may be very different in California or in Nebraska if you change these variables. In the same way to say that bricks or titratable acidities are different amongst these regions as well, even if it's the same grape variety. What you want to have, just like with TA and bricks, if you want to know what your TA is, give you a rough idea, but wouldn't it be better for you just to measure it yourself? Same thing with sulfur. And what we wanted to do is come up with a quick, easy method for measuring sulfur residues that people could use if they suspected they had high sulfur residues. They wanted to use it as a criterion for receiving grapes, or as a grape grower if they were concerned about excess residues. So the properties of the method, it's relatively cheap, it's relatively quick, and you don't need any specialized equipment. So how the method works, in a nutshell, we simulate what happens during fermentation. We start with elemental sulfur in our must. We remove all of the air with the antacid tablet, and just a seltzer. Then we add a reagent that converts all of the elemental sulfur, S0, into H2S. So just like what happened during a fermentation. And then we use an acid tablet to push all H2S into a gas detection tube. They look like these. They look like little thermometers. These are coated with a material that will change colors when it goes to H2S. If any of you have ever done any work with environmental safety or workplace safety, you might be familiar with these products. They're called Rager tubes after one of the major manufacturers. We prefer a company called Gastech that makes these. They're used for detecting a wide range of gases, and ones that we use are designed to detect specifically H2S. And the chemical reaction that occurs then is with lead acetate, which makes this black lead powder. There's some other chemistries available as well. The key thing is that the more H2S is present, here very little, here a lot, the more darkening you get. And so you can relate the amount of darkening to the amount of H2S that was formed, which means you can relate that to the amount of elemental sulfur that was originally in your grape sample. Okay, so if you want to learn more about the method, this is the instrumentation that you need right here. That is about $20 worth of materials right there. A flask, you will need to get a power drill or some other way to punch a hole in the top. You use this then to connect up with some tubing to one of these gas detection tubes, and that's it. All you need after that is your reagents, and which you buy commercially, and you can find out both the full protocol and a list of suppliers where you can source some of these reagents online. You can also see a YouTube video to see how to do the method. You can also get in touch with us if we do some fee-for-service work as well. The most important thing is you actually have to have the grape sample. We can't do this retroactively on wine. The methodology does not work in finished products. It's only appropriate for grape and juice samples. Okay. So here's some work that we did in our lab. This is Misha Kwasniewski, who was a grad student with me. He did the work. Now at University of Missouri. What we see is even in grape samples where we have no elemental sulfur, you always get some hydrogen sulfide. That's what the y-axis is, hydrogen sulfide. Always get some H2S production. And here we supplemented with nutrients, and this helps keep the H2S production relatively low, but it could be higher depending on the grape variety and the yeast strain. Once you start increasing residues, this has the same nutrient status. We're starting to see conversion of that elemental sulfur into H2S. And we're getting more and more H2S formed, and this corresponds to a point right around 1 milligram per kilogram, 1 part per million. And this corresponds with what previous authors have reported with where the danger point starts with elevated H2S production. Okay, so the key thing then as a vineyard manager is how am I going to get to this 1 milligram per kilogram? Because what we did in this trial was just add the elemental sulfur right in, or use treatments that had very high elemental sulfur. Well, what if you want to avoid getting to that 1 milligram per kilogram level? And we field trials in collaboration with Wayne Wilcox at Cornell in plant pathology. You can read through the information. The main thing that we were trying to do was use a range of treatments, so different application rates, different formulations. We did not use dusting sulfur, but we did use wettable formulation and micronized and microthiol formulation. And then we varied the pre-harvest spray interval. That is, when was the latest that we sprayed? That answered the question of how late can I spray? We took samples at regular intervals, and we did this in a randomized block fashion to correct for any variation within the vineyard. Okay, here's some of the examples from 2010 from one of the grapes we looked at, Chardonnay. We stopped spraying at almost 2 months, 5 weeks, 3 weeks, about a week. A couple of different formulations of sulfur, micronized product, a wettable product, and the wettable product at 2 different rates. And the outcomes. Well, here's actually this is in the 2009 growing season where it was rather wet. Here's what happens when you use a control. That was a very poor control where there was no spray application. You get what I call poor man's ice wine, which is little zombie powdery mildew berries. If you actually do spray elemental sulfur or some other pesticide, this isn't an issue. So what we observed, and we observed this in some other trials as well from 2009 to 2010, is if you what was I going to say? If you stop spraying around 5 weeks, you're in pretty good shape. And definitely if you stop spraying by 7 weeks, there is almost no detectable residue. And the amount that is there is below what is associated with excess H2S production. So most of our trials fit this model, where if you stop spraying by about 5 weeks, maybe between 5 and 7 weeks, then there is no sulfur residue or negligible sulfur residue on the resulting fruit. So that's the punchline everyone wants to hear. Most of the trials, you can just stop spraying 6 weeks. Here's the problem. Then we go to one of our treatments in 2011. Same formulation, slightly different rates, but not that different. Pretty much the same pre-harvest intervals. We had to vary that a little bit due to changes in harvest timing. And now what we see is even out to almost 2 months with microthiol and this wettable cumulus product at the highest rate, we're in the danger zone. So what's different between the two? We're not really sure, but we have some ideas. 2010, 2011, late season, we had a lot more rainfall. So it's thought, at least in the East Coast, with these wettable products, that the most likely way that they're lost is due to weathering, due to storms, due to rain. With dusting applications, dry climates, West Coast, it's very likely this is due to volatilization and perhaps photooxidation. But we think on the East Coast and the Midwest and other cooler, wetter regions, the major route for loss of sulfur is going to be due to rain. And the other thing that would point out is the data. 2010, if you double the application for wettable sulfur, you roughly double the amount of residue. That makes sense. Microthiol, billed as a more sticky product. It's got a surfactant in it that helps it cling to the berry. Sure enough, it does that. One other thing I'd point out is that you're spraying late season like this. Your goal is not to get your sulfur onto your grape berries. Powdery mildew is not going to be able to establish itself on grape berries once you start accumulating sugar. So any spray that ends up on your grape berries is gotten there generally by accident. You're probably aiming your sprayer at your canopy, not at your grapes. Well, we're with our trials, somewhere between 5 and 10% of what got sprayed ended up on the grape berries. So this is going to be an important variable in determining how much of an effect sulfur is going to have at harvest. How well tuned is your sprayer? Do you have a big gap between your fruiting zone and your canopy? Are you selectively applying your sulfur spray to your canopy? The more the answer to those questions is yes, the less is going to end up on your fruit, the less is going to show up at harvest. Okay. So one of the things we're working on right now is how can we explain what's driving the loss of sulfur residues. Why do we see, for example, we stop treatment at 35 days before harvest. We see this rapid decrease, and then it just plateaus. And then it starts decreasing again. We have some limited data, as in this particular data set, showing there was a rainfall here and not here. Based on 1 year's worth of data, we're not going to be able to make big claims. We suspect that one of the major forces resulting in loss of these wettable and micronized products is rainfall, but that's an ongoing question. Okay. So what I just described is what you should care about if you are skin fermenting your grapes. Because if you skin ferment your grapes, most people aren't washing their grapes or trying to scrape off sulfur residues. Whatever's on the grape skin is ending up in the must, in your crushed grape berries. It's ending up present during fermentation, accessible to the yeast. What if you are making a skin fermented, what if you're making a white wine instead of skin fermented wine? This is a good time, I think, for a break. So if you want to start entering questions, this would be a good time for me to entertain them.
Okay, we haven't had any questions come in. We have had a little bit of chatter in the chat pod now, and actually during the noon session, regarding timing of nutrient additions during fermentation. So do you have anything to add about that, Gavin?
Yeah, and Chris, you're there too. And I think Galen has asked a question about that.
Yes.
So the first thing I want to state is this discussion of elemental sulfur's effects is independent of the effects of nutrients. You can have the finest nutrient status of any grape juice in the world. If you have elemental sulfur present, the yeast are going to convert that to H2S. It does not matter what your nutrient status is. This is a separate pathway. And there are yeasts that have been modified to try to minimize H2S production. They produce just as much H2S from elemental sulfur as other yeast strains. So this is it leads to the same endpoint, which is hydrogen sulfide, but it's a different pathway for its formation. But we can still talk about the other pathway, which is the effect of yeast nutrient status on H2S formation. Hey, Chris, are you there? Do you want to give the latest advice that you guys are giving regarding yeast nutrient additions to try to minimize hydrogen sulfide formation?
I actually don't know if Chris has a microphone, so he just might type a little note. Okay.
Yeah. This is not my area of research, so part of what I do is respond to what I see in the literature and what I see okay, I see Chris can't talk, so it'll take a while. I can go ahead and try to chime in. The current recommendations are to, so in grapes, most grapes, the major source of nutrient deficiency that's going to occur is going to be nitrogen. Grapes, for the most part, have most other vitamins that they're going to need, although there can be occasional exceptions. But especially here in the East Coast, New York State, there's several grape varieties notorious for being low in nitrogen that is available to the yeast. And there is the recommended amount of nitrogen is at the bare minimum between 150 and 200 milligrams per liter, and that scales up with increasing sugar content of the grapes. And I saw one of the, I think it was Galen, that had commented that he doesn't add it all at once. That's important. What's recommended now is to do staggered additions. That is, you add one portion at the beginning of fermentation, another approximately 1/3 of the way through. There's good evidence showing that once you get past about 8, 9%, 10% alcohol, yeasts struggle badly to take up additional nitrogen because of the high ethanol. So if you're adding it too late, all you're doing is just creating nitrogenous substrates, extra nitrogen that can be present in the finished wine that can serve as food for sporulage organisms. So early additions are better. Staggered additions, in combination with a little bit of aeration. Yeast, even though they're anaerobic creatures, they produce lots of CO2, they prefer to have a little bit of oxygen as well to help them make their cell membranes. And I see Chris right now is posting some links with some recommendations. For nitrogen additions, when you are struggling with either stuck or sluggish fermentations, which often goes hand in hand with excess hydrogen sulfide production, and the fermentation's having problems getting underway, then a combination of aeration, so that can be done by racking the wine, it can be done by pump overs. Aeration plus some nitrogen is a good idea. Once you get past about, I think it's around 8% alcohol, that nitrogen addition is not going to help, although a little bit of aeration sometimes can. But I strongly recommend going to some of these resources that Chris is posting on the chat blog to get more details about the current conventional wisdom for dealing with stinky fermentations. Hey, wow, they keep on coming. Thanks, Chris. Yeah, this is it is not an unusual topic. So going the other way, though, excess nitrogen has its own set of problems, although none as severe as not getting your fermentation to go to completion. But adding too much nitrogen can run the risk of too fast fermentations, especially hot fermentations, production of some undesirable aroma compounds. And if you add more nitrogen than the yeast can use, you're just leaving substrate around for eventual spoilage. And finally, I know in Canada, I was talking to someone recently who added nitrogen to the legal limit without measuring how much nitrogen was already present in their must. Their wine was rejected for sale by LCBO, by Ontario, because they produced too much ethyl carbamate. Which is associated with, it's a known carcinogen, and it's regulated in some countries. So this is a byproduct of having too much nitrogen to begin with and then adding more nitrogen. So it's possible to measure nitrogen. You can do it yourself through some of these resources, or you can set it out for analysis. And then I also see Gail and Haddock asking about nitrogen, and Chris has responded, which is, yes, it can be manipulated in the vineyard, but it can be, the problem, so I see Chris saying, is trying to heat up the neighborhood. Yeah, one of the downsides of heating up the neighborhood is increased nitrogen application in the vineyard is associated with more overgrown canopies, which is often what people don't want to see, runoff, which might be regulated, and increased incidence of rot.
Yes.
Because you are creating more nitrogen in the vineyard, more nitrogen in the berries, and leaves, which is then more substrate for various spoilage things in the vineyard to get going.
Yeah, and some work that we've done here that Tim did, trying to add more nitrogen, we ended up with a lot more botrytis, but really not that much more yan in the wine or in the must. So it's really not. It's hard to know whether it's going to really increase your yan or not. So, yeah, like Chris said, the connection is not direct. So, yeah, it's not really, I just don't think it's the way to go, really.
The one exception I would say is if you, because what the main thing driving nitrogen is frequently not nitrogen availability, it's often water availability.
Yeah.
So adding more nitrogen, especially if you already have plenty of available nitrogen for the plants, if you're growing grapes on a place that was used for other agricultural purposes, this is very common. Adding more nitrogen might do very little. I know if you're producing grapes for yield in a hot climate, for example, the Central Valley, then doing fertigation, nitrogen, water makes a lot of sense, because then you can make huge vines, lots of yield. But wait, what's the name of the seminar series again? Northern Grapes? Never mind. So ignore what I just said.
That's okay.
That was about another climate.
All right. Well, I think that we have all the questions that have come in so far addressed. So if you want to keep going, Gavin?
Sure. Galen, just so you know, you've already used up your questions. Anything additional you have to pay for, and we accept credit cards. You can just type it right into that chat box. Okay, good. Let's keep going. MasterCard and Visa are accepted. Okay, so, oh, yeah, Chris said I'm kidding. Fine, I'm kidding. You have to include 25% for indirect, by the way. So where we left off, skin fermented grapes for making a red wine. Everything I've said up to now is relevant to making a red wine. If we're making a white wine, this is less relevant, because what is on the grape doesn't necessarily transfer to what is in the juice. So with the white wine production, we take the grapes, we crush them up, maybe we press them immediately, that's not uncommon, and we get this turbid, cloudy juice, and then we look what's in the juice compared to what's in the wine, and there's a pretty good correlation, but it's not all of that sulfur residue. It's about half the concentration. So this has a small effect, simply crushing the grapes, but there's a bigger effect, which is, do you clarify your must? And I'm going to talk a little bit about more of this in the next slide. But here's the effect of allowing that cloudy juice to settle out at slightly cool temperatures. Sorry, not slightly cool, at refrigerator temperatures. So at hour 0, this is with a treatment where we sprayed less than 2 weeks before harvest. We're in a real danger zone here. 12 parts per million sulfur residues, 12 micrograms per gram. That's going to lead to a very stinky winery, let alone what the wine smells like. But within 12 hours, or 14 hours, we have almost undetectable sulfur residues, and below any problem level any levels associated with problems during fermentation and excess H2S, and definitely by the time we get to 1 day. So this is, by the time we get to 1 day settling, we can't tell the difference between our treatment that we did at 2 months and our treatment that we did at 2 weeks. So what this should emphasize is the importance of clarifying your must, especially if you're trying to avoid contamination from sulfur residues or other pesticides. Clarifying must, that is trying to remove the cloudy, turbid, suspended particles in the must prior to fermentation, is common. What's not so common is measuring to determine how clear is your must. So if I go back 1 slide, I don't know if these units are familiar to you. 420 NTU, 20 NTU, these are a measurement of turbidity. The one on the right is, I think, 1,000 NTU, 100 NTU, and something like 10 NTU, I think. When you first crush grapes, they're somewhere close to 1,000. You wait maybe an hour, and it's down to about 400. You wait 12 hours at cold temperatures, it's usually down to around 100. This will depend on your temperature. Incidence of disease can affect settling time, and the viscosity. The best thing to do, again, is to measure. And it's not that hard to make that measurement. There are devices sold for making turbidity measurements. You can also, at the very least, take a look to see how clear it is, but it's even better if you can take that measurement. Or if you have a centrifuge, you can take what's called spin solids, put the wine into a little centrifuge tube, spin down, and see how much stuff pellets out at the bottom. I think, Chris, you probably could direct people to appropriate resources if they want to learn more about clarifying their musts. What I've been talking about here is cold settling, but there's other approaches as well. If you've got the means to do it, there's flotation, where you add something to flocculate out your solids. There's filtration, there's centrifuges. There's a wide range of techniques that are used for clarification, but the most common in small, mid-sized wineries is going to be cold settling. You just let most of the solids sink down to the bottom, and when we do measurements, we find that we can account for where all that missing sulfur is. It's in the tank bottoms. And it's no longer in your clarified settled must. Point of caution. If you are in the habit of doing something with your tank bottoms and trying to make a low-end product, I would strongly recommend cleaning that stuff up as well as possible. So a good defiltration, perhaps even a little bit of charcoal, or even better, take a measurement. But this is one of the reasons that we clarify must for white wine production. It's to get rid of any pesticides that can lead to noxious off aromas. It also promotes the formation of ethyl esters and some other nice smelling compounds, and decreases the formation of some stinky things beyond just H2S. So my recommendation is measure your turbidity. That's the best way to know if you've clarified your must acceptably. Okay, so if your residues are too high, what do you do? Assuming you know that they're too high, maybe you can see it. I've seen grape samples that people brought in where you could actually smell the elemental sulfur. And there's sometimes we can't do it, but we can make a measurement and show there's too much elemental residue on this grape. Delay harvest, maybe. Weathering will remove elemental sulfur, and that assumes that you have the flexibility and the guts to delay harvest, especially if there's something really inclement coming around. Wash the grapes, probably not realistic. If you're trying to make a white wine, good news. All you have to do is make sure that your juice is well clarified. I didn't show data here, but skin contact, if you crush and then allow for 2-3 days of cold skin contact before fermenting, before pressing and fermenting, that will increase sulfur residues in the final juice and then in the more H2S in the fermentation. If you have contaminated fruit, don't do skin contact. That goes for pesticides, that goes for disease, that goes for a suite of problems. If you've got a red that's contaminated, do you really need to make that red? Maybe you can at least isolate it, but you can also consider making a rosé instead. Furthermore, if you're a grape grower and you're tired of being accused by a winery, or if you are a state vineyard and you want to know, are we part of the problem, you can confirm when it's not the case, that elemental sulfur isn't the problem, because as I mentioned before, and as has come up, H2S is one of multiple pathways. Sorry, elemental sulfur is one of multiple paths to make H2S. You can also have yeast nutrient issues and some other poorly defined issues. Okay, so the last several slides I want to talk about some ongoing work in our lab, which is reconsidering how we define what the right metric is. That is, what is the right way to define the limit for maximum S residue? I've been saying it's about 1 milligram per kilogram, 1 ppm, based on making more H2S during a fermentation. If you make more, that's too much. But I want to bring up another idea, which is, what if we should be defining this based on the ability, so the reappearance of hydrogen sulfide during bottle storage? Okay, so what am I talking about during bottle storage? Here's a nice experiment that was done a few years back, looking at the effects of different closures on a wine during storage. This was a wine that was bottled with no hydrogen sulfide, no detectable hydrogen sulfide, so less than 1, I think was the detection limit, less than 1 part per billion, below sensory threshold. They stored this wine for 2 years. And when they have very anaerobic conditions, so a saran tin screw cap lets very little oxygen in, then they end up with much higher concentrations of hydrogen sulfide in that wine after 2 years of bottling. With a synthetic closure that allows more oxygen in, they have very little. Hydrogen sulfide is easily oxidized, and so this has been one of the subjects of recent research, which is trying to understand the effects of closure and oxygen ingress, how much oxygen gets in, on H2S and other reductive aromas in a wine. What's been less studied is what's the effect of the wine. So let's say we keep the same closure, screw cap only, or natural cork only, or some other closure. Some wines will produce H2S during storage and some won't. Why is that? Why do some wines make H2S during storage and other wines don't? Why do some wines smell reductive and like cabbage and natural gas and rotten eggs, and others don't, even if they have the same packaging? And so there's several hypotheses in the literature. These are not mutually exclusive. They all could be true. Well, I think number 3 here is wrong, but I think the other ones have a strong possibility. So one possibility is that there's degradation of sulfur-containing amino acids during storage. There's some pretty good data to support this. I would point out, where is this cysteine, this amino acid, coming from? It's left over from fermentation. Why is there sulfur-containing amino acids left over after fermentation? Because you added too much nitrogen. This is a consequence of excess nutrient additions during fermentation. Okay, reduction of copper sulfide complexes, kind of interesting. This is just come out, but it looks like sometimes when you add copper to remove hydrogen sulfide, this is a common way to try to get rid of sulfurous off aromas. This is copper addition. It doesn't all precipitate out, even if that's what the textbooks say. Some of it stays suspended in the wine and can gradually and reversibly reform hydrogen sulfide. And there's a couple of other hypotheses, and I want to focus on this last one, sulfur pesticide residues degrading in bottle. So here's an experiment that we did. We took wine from our different sulfur spray treatments. We sparged to remove hydrogen sulfide because they produce different amounts of H2S. And then we bottled and stored those wines under a nice closure and checked for new H2S. To say this again, took the wines, put them in the bottle, and then looked to see how much H2S showed up during bottling. And the answer is there's some H2S that shows up during bottling, and it correlates very nicely to the amount of elemental sulfur that was present at fermentation. So what we're trying to understand now is, how does this work? Where is that elemental sulfur going? It doesn't make sense. It shouldn't be sufficiently soluble to stay in the wine. We think there's a degradation product from the yeast metabolism that's able to be solubilized in the wine that can gradually degrade and make H2S during storage after only a few months. So this is part of our ongoing work. And to wrap things up, we have a method for quantifying sulfur residues on grapes and in must. You can learn more about this online, or you can send me an email if you want more details. Rule of thumb, for the most part, what we see is 5 weeks pre-harvest is a reasonable pre-harvest spray interval for sulfur sprays. But 1 year out of these 3, even seasoning sprays at 2 months wasn't enough time for all the sulfur to disappear. And we'd recommend, if possible, that you actually do a measurement. The wetter your environment, the less likely this is going to be an issue. And also, if it's a white that you're making, as far as I can tell, if you clarify your juice well, you can spray sulfur directly into the picking bin, and it will not be an issue. If you clarify your must well, you can spray while you are delivering grapes to the winery, and it won't be a problem. The problem is if you don't clarify well. But most of that sulfur residue will drop out with the solids, and it will not be an issue for your fermentation. Okay, future directions, trying to understand how these sulfur residues affect long-term wine quality, and particularly in-bottle formation of hydrogen sulfide. Okay, I think this is a good time to wrap things up and answer questions. And I think, Chris, I saw that you had something that you wanted me to remind people about, which is the dangers of over-clarification as well. Is that right? I see a question that could cause stuck fermentation. Is that what that's in reference to?
Yeah, yeah. Chris was clarifying Galen's question, whether he meant by it causing stuck fermentation, whether it was over clarification or it was too much sulfur. So, yeah. And then, yeah.
So there's been a little bit of data on the effect of elemental sulfur residues at the concentrations you could realistically expect to find them in a must. Sulfur is a fungicide. You expect that it should delay fermentation somewhat. It's a tiny delay. It's not as much as some other, at least at the concentrations where it's usually present, it's usually not a major effect on fermentation kinetics. The bigger problem is the formation of the noxious off aromas. There are other fungicides, though, whose names I'm completely blanking on. I want to say excess DMIs can cause this problem, where you can see a delay in fermentation, but I don't want to promise that. Over clarification, to go back several slides, I mentioned the dangers of clarifying too little. That is, you're going to have more sulfur residues stuck to your solids. Going the other way, you don't want to clarify too much. You don't want to have insufficient solids in a white ferment. Yeast, for reasons that are still a little mysterious, need to have some sort of particulate matter, insoluble solids present to complete a fermentation in a timely fashion. This can be grape solids, but it's even possible to add back inert solids like DE, like diatomaceous earth, and solve problems. But if you have too low a turbidity, if your juice is too clear, it's like the color of water, then that fermentation can be very slow and sluggish. One of the hypotheses is that the yeast needs something to hang on to help separate out well and get suspended in solution. Another hypothesis is that the solids help nucleate CO2 and make CO2 bubbles, so the CO2 will leave solution and not give the yeast the bends, I guess, and excessively acidify the wine. So under clarification and over clarification can both be issues with white wines. The sweet spot is somewhere in between these two extremes. for most white wine producers. Somewhere between 100 to 200 NTU is usually recommended.
Okay, and then Peter asked a question that came in just to me, if there are any other pesticides besides elemental sulfur that can be a source of sulfur.
Yes, but I haven't seen, so Chris, you've looked into this a little bit, and you might want to chime in. There are some reports back from the 80s and the 90s looking at the effects of various products. A lot of them, as far as I can tell, aren't used, so don't do off-label uses of pesticides. The one thing that always comes up is Captain a problem? Because that is sulfur containing, and the answer is no. Captain is, there's other issues with having high amounts of Captain in fermentation, but H2S production is not one of them. It will delay fermentation kinetics, I believe. Chris, I don't know if you have anything to add to this. There most certainly are reports of other sulfur containing pesticides leading to problems. But the ones that I'm aware of from the literature, no one is using for grapes, and it's not it would be an off-label use. So my recommendation is don't do off-label uses of pesticides.
Not just because your fermentation might get stuck or you might end up with some H2S. So.
Yes. Well, I'm a flavor chemist. That's the only thing I care about. But I'm sure there's other, legal reasons as well.
There would be some legal reasons. Yes. Yes.
And Chris, I see his comment. They're looking at a few other fungicides. I think they've seen problems in 1 year, and oops, pardon me. They're looking just at 1 year, and they are looking only at the recommended pre-harvest interval. Elemental sulfur is a little different, though, because the recommended pre-harvest interval is actually, from a safety perspective, is relatively short. It's the main issue is for fruit for wine quality rather than for human health.
Yeah. Well, those are all the questions we've had. So let me grab control back, and I want to pop up well, first, let me tell Gavin thank you. It was a great presentation. Also, thank you, Chris, for being on hand to answer questions. We appreciate that. Thank you, everybody, for participating tonight. Webinars are always a lot more fun when we have more people. So with that, I want to share the upcoming Northern Grapes Project webinar series schedule. We still have 4 more this season coming up. I hope that some of those are going to be of interest